Hi, welcome back to Mrs. Ogram's Maths. This time we are taking a look at a differentiation parallel paper that is focused on achieved and merit. So it's the first three parts of each of the three types of questions you get in the external. So the first two are usually worth achieved, and then the third part is worth a merit. So that's what we're looking at today. Okay, so 1A, we could either use our product rules in terms of adjusting what we have here to begin with, or we can use the product rule of differentiation. I'm going to go with adjusting this one. So look at the product rules on your formula sheet, and you've got this one. So 6 cos 3x cos x will be equal to 3 of cos, add up the 3x and the x, so we get 4x, plus 3 cos of, oops, actually we don't need that bracket there, so just 3 of that, plus 3 cos a minus b, so that's the 3x minus the x here, so 3x minus x is 2x. So just making that a little easier first, so y is equal to 3 cos 4x plus 3 cos 2x. So dy by dx will be equal to, well, cos goes to negative sign, and we multiply by the inside of that function there, so we get negative 12 sine 4x and negative 6 sine 2x. When x is pi by 3, dy by dx is equal to, and we'll do it all on the calculator over here. And we get the answer of 5.2. For part B, we are using the chain rule here, so dy by dx means that we bring down the 3, reduce the power by 1, leave the inside where it was, and then multiply by the derivative of the inside, so we've got 12x plus 2. You don't need to simplify it. For part C, we've got find the value of x for which the graph of this function, ln x over x, has a stationary point. So stationary points happen when dy by dx is equal to 0. This one is a merit question. And we need to differentiate y to find dy by dx. So we use the quotient rule here because we've got one thing divided by the other. So we've differentiated the u and the v. Then we do this one first. V du by dx, multiply them together, we get 1 minus u dv by dx, so that is the natural log of x, and divide it by v squared, which is x squared. Now, if we are looking for a stationary point, we want to know when that equals 0. So working that through, 1 minus the natural log of x is 0, so the natural log of x is equal to 1, and if we want to undo the natural log of x, we use e. So shift natural log gives us the e of 1, x is equal to 2.72. Now we've just done a quotient rule, now we're moving on to a product rule for this next one. Two things multiplied together, so u is x squared, v is tan x. du by dx is equal to 2x, and dv by dx is equal to sec squared x. Multiplying them, putting them into the product rule gives us, we do u times dv by dx, so x squared sec squared x plus v times du by dx, so 2x tan x. For part B, we want the rate of change. That's just another way of saying the derivative. So since this is in function notation, we'll write it as f dash of x. And if we're doing that on e, then we differentiate the thing that is at the inside of that e function, so the power of e here. If we differentiate that, we get 2, we bring it down and we multiply by what's in front, the 3 there, so we get a 6 e to the 2x minus 4. So when t equals 3, f dash of 3 would be 44.3, and you can see over at the side here where I put that into the calculator. Okay, for part C, we've got the merit part. Find the x-coordinates of any stationary points on the graph of this function. So we want to find the derivative, set it equal to 0, and solve it. So if we differentiate 5x, we get 5. Now we're going to take away the derivative of x log x. Now this is a product rule where we've got u is natural log of x, and u is x and v is the natural log of x. So if we differentiate du by dx, we get 1. If we differentiate dv by dx, we get 1 over x. So we multiply u by dv by dx, and we get x over x, which is 1. And natural log of x times by x will be just the natural log of x. We add that on there. So then if we take out the brackets, it turns this into a negative log. So, right, now we want to find the stationary points. So we set them equal to 0 and start solving. So 4 minus natural log of x is equal to 0. So the natural log of x is equal to 4. X is equal to e to the 4, which is 54.6. Okay, question 3. First part, we are simply differentiating this. I'm going to put it into powers first. So this is x to the minus 2 minus 6x plus 7 to the power of a third. So dy by dx will be minus 10x. And if we reduce the power by 1, we get a negative 3. That's where lots of people go wrong. So minus 2 take it down, 1 is minus 3. Then we have minus a third 6x plus 7, reduce the power by 1, so 1/3 take away 1 is negative 2/3, and multiply that by the derivative of the inside, which is 6. We can tidy that up, it's not absolutely necessary. I really don't like it how it is. We want the 6 and the third together, so this will be 6 divided by 3 is 2. Part B, we want to find the values of x for which the gradient of the tangent to the graph of the function of this is equal to negative 2. So f dash of x is equal to, well, sine goes to cos, and we times it by the 2 that was inside that bracket, so it's 2 cos 2x plus 1. Okay, so then we set that equal to minus 2 and solve it. And then knowing the graph of cos looks like this, we want to know where does that equal minus 1. So there's the minus 1 just there. That only happens in one place, and it's at pi. So 2x plus 1 is equal to pi, and x is equal to pi minus 1 over 2. Okay, part C, the normal to the graph of that function at the point 11, 4 also passes through another point A0. Find the value of A. So we've got y is equal to x plus 5 to the half, and this one is a merit question again. If we're needing to find the normal, we'll need to find the gradient of it. So that'll be half x plus 5 to the negative half. So we need to find the gradient when, so the gradient of the tangent when x is 11 will be 1/8. So the gradient of the normal is the negative reciprocal of that. So negative 8. Now we know it passes through 11, 4, so we can find the equation y minus y1 is equal to mx minus x1. So y minus, well, the y coordinate up here that we've got here is 4, is equal to the gradient, which we know is minus 8, x minus 11. And what we want to work out is the x value that gives a y value of 0. So if we put 0 in for y and solve that, we can get what x will be. So x will be 11.5. So therefore a is equal to 11.5.